So here we have integration over one time step. We want to extend that to integration over n time steps, which means we need to repeat these statements n number of times. And we can do that by looping over these statements. And to see how to loop over statements, go into the search documentation field and type in your search term, which let's say is loops. Okay, and that brings up the help browser. And you can see that if you use the for function, it executes statements specified number of times. And if I click on the link for that and scroll down, it gives me a general description of the function. And here it gives you an example. So, the examples tend to be very useful. And so you can see in this case, in this example, you have two loops, one nested inside the other, whereas we have only one. So you start off the loop in this way. So let's go and implement that. So I will switch back to the main MATLAB window. And I will say, so I'll create a new line. And I'll say for, I'll call my counter I equals 1 colon n. So this will loop through it from I equal to 1 to I equal to n. And if I go back to the help browser, I see that I have to end the loop using the end statement. So I'll come down here and give the end statement. And so visually MATLAB shows that this loop applies to these three statements. And visually, for code readability, it's good to indent, the statements within a loop. So I'll highlight these three statements and just use the tab to indent. Okay, and if I run this using F5, I see that now after n time steps, my x location is 4.1, about 4.13. Whereas in this case, so this is a cosine function. So the solution is just, the exact solution is just cosine of root of k over m times t. After one time period, I expect the location to be the same as the initial location. So, but you can see that this is very much different from 1, and I suspect that that's because my time step is pretty big. So if I go back here and increase the number of steps and rerun it, I see that it gets closer to 1. And as you keep increasing n, it'll get progressively closer. But you can see that even with 100 time steps, you're getting like a 22% error in the location after one time period. And that, so you have to refine the time step a lot in the Euler's method to get an accurate answer, which is why people use higher order accurate methods such as Runge-Kutta.